Assalamu alaikum everyone. So in this class we are going to solve AS paper October November variant 1 2. Okay, so let's begin with the first question. In first question, the examiner is asking us what is the reasonable estimate of the weight of an adult? Okay, so weight we know W is equals to mg, and if we estimate the reasonable estimate for an adult mass is 70 kg, and for estimation you can take g equals to 10 or you can even take 9.81. So it is 17 to 10, that will give you 700 newtons. Okay, so it can be written as 7 into 10 raised to power 2. It's option B that is correct. In question 2, what describe a set of data with a high precision? So high precision is when data is close to each other. That is called more precise data. Okay, so it's option D that is correct. In question 3, which physical quantity could have a units of Newton second square per meter square? Okay, so let's solve this Newton second square per meter. If I solve Newton is for the force, it is kg meter per second square, and we have second square and per meter already. So if you see, this second square will cancel out with this thing, this will cancel out with this thing. We're only left with kg. Kg is for mass. It's option C. In question 4, a ball is released from the rest, and okay, so let's highlight the important point is released from the rest. The distance the ball falls and the time the ball take to fall, that distance are both measured. The percentage uncertainty is measured and distance is negligible. Okay, so the D uncertainty is negligible. The percentage uncertainty in time is given as 4%. The distance and the time are then used to calculate the acceleration. A resistance is negligible, so A is, if A resistance is negligible, it's mean acceleration is constant. Okay, that is equals to G. What is the percentage uncertainty in the calculated value of the acceleration of free fall? Okay, so if you remember, to find the free fall acceleration, you can use equation of motion. Okay, because acceleration is constant. So what we have distance s, we have time is also involved in this, and acceleration is also involved in this. Okay, and initial velocity is also involved in this. So the equation that is best fit is s is equals to ut plus half at square. Okay, so as we know, initial velocity is 0, so this term will be 0. So s can be written as 1 over 2 at square. What we have to find, we have to find acceleration. So making a subject will give us a is equals to 2s divided by t square. Okay, when working out the uncertainties, we know whenever the percent quantities are multiplied or divided, their percentage uncertainties will be added up. So percentage uncertainty of a will be equals to percentage uncertainty of s plus 2 multiplied by percentage uncertainty of t. This 2 is multiplied because there is a power 2, that is a power factor. Okay, as given, this uncertainty is negligible. It is given in the question, this condition. So, and the uncertainty of the time is it's 4%, so it will give you 8% total uncertainty. So it's option C that is correct. In question 5, a car has an initial velocity u. The car then moves with a constant acceleration in the straight line through a displacement d. The car reaches a final velocity v. Which expression gives the initial velocity u of the car? Okay, so what we have um, u is involved in this. A is distance, s is equals to d, and you have v. So as the acceleration is constant, we can apply equation of motion, right? So to apply equation of motion, the best equation is, because time is not involved in this, you can use v square is equals to u square plus 2as. Okay, what we have to find expression for? We have to find for u. So let's make u the subject. The u square is equals to v square minus 2a. S is equals to d, so I can write it as d. And if you want u, you have to take square root on both sides. So u is equals to square root v square minus 2a d. It's equation B, that is correct. Moving forward, question 6. A bicycle brakes so that it undergoes a uniform deceleration from a speed of this. Speed is basically, this is the initial speed to the final speed over a distance of 7 meters. The deceleration of the bicycle remain constant. Which further distance will the bicycle travel after before coming to rest? Okay, so what is the condition? We have some track. So let's try to build the scenario. Let's suppose this is the track. This is the starting point. It has a speed 8 meter per second here. This is another point where it has a speed 6 meter per second. And from this to this, the distance is 7 meters. And after this, it will decelerate. It was decelerating earlier as well. And the acceleration will remain zero. There it come to rest. You have to find this distance. Okay, this is, you have to find. Okay, so first, and what we have, mm, okay, this is all that we have. So first we can do, this is u, there is v, there is s. I can find a from this thing, this data. So a can be, because the same a will be here after 6 meter per second speed. Okay, so to find a, I can use the equation v square is equals to u square plus 2a s. I'm solving for this journey. Okay, so a will be equals to v square minus u square divided by 2s. Putting the values, v is 6, u is 8, and s is 7. This will give us minus 2 meter per second square. Okay, now let's solve it for the this portion. Okay, now we have acceleration is minus 2 meter per second. We have to find s. So what we can do, which equation of motion will be applied? The same equation of motion can be applied in this case. So I can use, now I have to find s. So v square is equals to u square plus 2as. For this journey, this will be the u and v will be 0. Okay, so putting the s is equals to v square minus u square divided by 2a. V is 0 square minus u is minus 2 whole square divided by, sorry, u is not minus 2, u is 6 divided by 2 and a is minus 2. So it will give me minus 36 divided by minus 4. So the answer will be 9 meters. Okay, so it's option B, that is correct. In question 7, the velocity time graph for an object is shown. Which expression give the total displacement of the object? Okay, it's the velocity time graph. So if you see, this velocity is positive here, velocity is negative here. So for this journey, it is moving in one direction, and this it is moving, if in this it is moving forward, for this it is moving backward. Okay, so this area is showing the distance in forward direction, and this is showing distance in backward direction. So the displacement will be the difference of these two areas. So it will be the option A, that is correct. In question 8, which statement describe the weight of an object? It's a pretty easy question. It's option C, that is, it is the force acting on the object due to the gravitational field. Okay, that is the most accurate definition for the weight. Question 9, What is a statement of the principle of conservation of momentum? So for the principle of conservation of momentum, the most accurate is the momentum of an isolate system is constant. Okay, that is the definition for it. In question 10, the diagram shows the view from above of the two balls moving along a horizontal frictionless surface. Before they collide, the momentum of each ball is also shown. The balls stick together during the collision. Which vector diagram represents the combined momentum of the balls after the collision? So it is simply addition of vectors. Okay, so I can use head to tail rule. It's also called tip to tail rule. Okay, so if you just imagine, let's suppose you can take any one of them as a first vector. Let's suppose this is the first vector. If I consider this as a second vector, what I have to do, I have to place the second vector onto the head of the first one. Okay, and the resultant will be from the tail of the first till the head of the last. So this will be the resultant. So if you see, this is option B that is making sense here. Okay, moving forward, question 11. The skydiver is falling at a constant velocity. She then opens the parachute. The graph shows the variation with time of the velocity. Which statement about the motion of the skydiver is correct? The magnitude of the acceleration is maximum at time t2. Okay, so basically slope here is showing the acceleration. So if you see, this is the maximum slope, so this is true. The magnitude of the drag force at time t1 equals to the magnitude of the drag force at time t3. Okay, if you see at this point and at this point, these both are the terminal velocities, and that is correct, that the magnitude of the drag force, both the drag force will be equal, and the drag force will be equals to weight, and weight remain constant, so both the drag force are constant at the terminal velocity. And the third, the magnitude of the drag force is maximum at time t1. No, the drag force is not maximum at t1. Drag force will be maximum when the parachute will be opened, so it will be at this point. Okay, so third is wrong, so it's option A that is correct. Okay, moving forward, question 12. Two different blocks P and Q slide towards each other on a horizontal frictional surface. The blocks have an elastic collision. The diagram shows the velocities. You have to tell which row give possible velocities of the two block immediately before the collision. Okay, so what we can use, if as the collision is elastic, okay, it is given in the question, it is elastic collision, so we know speed of separation should be equals to speed of approach. Okay, so speed of separation, as both are moving away from each other, so it is 20 plus 70, that is 90. Okay, and if you see, if which one will give us 90, 10 to the right, 60 to the left, it will give us 70, so it's not true. 50 and 0, it will give us 50, that is not true. 20, 70, I said this is to the left and this is to the right. P is moving left, Q is moving right. No, they are again moving away. Okay, so they will not collide, so this is also not correct. P is moving right and this is moving left. Yes, then they couldn't collide. Okay, so they have to collide now. So in C option, they are not going to collide if they move in these directions, so it's option D that is correct. Okay, and it's giving us the 60 plus 30 is 90, so this is okay. Question 13. Which diagram shows a couple? For couple, forces should be equal and opposite in direction. So it's A. Pretty simple question. In question 14, The diagram shows a uniform bar of mass m and a length L resting on a pivot at a distance x from the capital X. Okay. Okay. An object of mass m is placed on the bar at a distance y from the pivot so that the bar is in equilibrium. What is the expression for it? Okay. So first of all, as the mass of the bar is m and we know the weight will be acting at the center. So let's suppose this is the center. Here the weight will be acting. Weight of the is mg. So this will try to move it clockwise. So to stop this thing, you have to place the mass somewhere at this point. We don't know the exact position, but we can place it here. And it will exert a force. Its mass is small m in this. Okay. And this distance you have to consider as y. It's given in the question. Okay. Now you have to find the expression for the y. Okay. So if I see that, so for equilibrium, what we know for equilibrium, clockwise movement must be equals to anti-clockwise movement. Anti-clockwise movement is this one. Anti-clockwise is very simple. The force is mg. Movement is force into distance, right? Force is small m and g, and the distance is y. The distance we always take between the force and the pivot point. So this is the distance taken. But for the clockwise movement, the force is mg. Force is capital M and G. The distance you have to take is basically this distance. Okay, how we can name it? We know from this point till this point, I can write this thing as L by 2. So if we subtract this x from L by 2, this will give us this distance. So this thing can be written as L by 2 minus x. So this is the distance between this force and the pivot. Okay, so I can write it as L by 2 minus x. Okay, so it can be written as, if you see on both sides, this g will be cancelled out. So this equation will become m L by 2 minus x is equals to m into y. I have to find y. So y is equals to capital M over m L minus 2 minus x. Okay, let's see options. A is not, B is also not. There is no 2 here. Okay, so this is not the option. Okay, we have to rearrange this thing. We can take the LCM of this thing. If I take the LCM, it will give me L minus 2x, and there is 2. This 2 can go out, m over 2m, L minus 2x. So it is option C that is correct. Okay. In question 15, the mass and the volume of an object are varied. Which two changes, when made together, must increase the density? We know density is mass per unit volume. So if you have to increase the density, what you have to do, you have to increase the mass and you have to decrease the volume, because it's directly proportional with the mass and inversely proportional with the volume. So it's option C that is correct. In question 16, on Earth, a solid object that is fully submerged in a liquid experiences a upthrust of UE, and on Mars, the same object fully submerged in the same liquid experiences a upthrust force of UM. The acceleration of the free fall on the Mars is 3.7. Assume that the liquid density and the object volume have the same values on the Earth and the Mars. Okay, so density is same and volume is same. What is the ratio of UM over this thing? Okay, so UM over UE you have to find. Upthrust force formula is density into gravity G. So as it is on moon, so GM I can write, and volume is same. And for this thing you can write density is same on Earth and this. G of Earth, that is 9.8, we know, and V. This density, this volume will be cancelled out, and you will get Gm over Ge. Gm is given, that is 3.7, and G is 9.81. When you divide both of them, you will get 0.38. That is option A. Okay. Moving forward, question 17. A student attempt to drive the formula for the kinetic energy. She began by considering an object of mass m that is initially at rest. The constant force F applied to the object causes it to accelerate to final velocity v and displacement s. The kinetic energy gained by the object is equals to the work done on the object by the force F. Which equation does the student not need in order to derive the formula for? Okay, if you remember the derivation for the kinetic energy, you need this relation, you need this relation, and you need this relation. This is not required. Okay. In question 18, a ball fall towards the ground from a point X. Point X is 2.4 meter above the ground. Let's try to make the scenario side by side. Let's make it here. Let's suppose this is the ground and this is point X. This is 2.4 meters. Okay, and the ball rebound from the ground and rises to the point Y. Point Y is 1.8 meter above. Okay, let's suppose Y is here and this is 1.8 meter above the ground. A single value of the change in the height is used to calculate the change in gravitational potential energy of the. You have to find change in height. So it's very simple question. This is the initial height, this is the final height. So change in height is this thing. So what you have to do 2.4 minus 1.8. That will give you 0.6, option A. Okay. In question 19, the diagram shows a block on a slope. A constant force of 1.8 Newton is in a direction parallel to the slope is exerted on the block. This causes the block to move along the slope at a constant speed. Okay, so if the speed is constant, it means forces are balanced. Okay, the block move a distance of 8 meter along the slope and gain a height h. The work done against the frictional force is this. This is work against frictional force. The weight of the block is this. What is the value of h? Okay, so basically they have told us that the speed is constant. So as v is constant, it's mean there is no change in kinetic energy. Okay, basically we have to use conservation of energy. So whatever work you are doing on this block, some of the work is used against the friction that is given, and the remaining work will be used to gain the potential energy. Okay, the kinetic energy is not changing, so you can write work done is equals to work against friction plus gravitational potential energy that they have gained. Okay, so burden, total burden is, we have applied a force of 1.8 and it has covered a distance of 8, so that is a burden, and work against the friction is 4.8 joules, and gain in potential energy is mgh, we know. Okay, and how we can find mg? Mg is basically, we have the weight of the block, where it is, there it is. Okay, so mg is basically 4. Okay, so h can be written as h is equals to 1.8 into 8 minus 4.8 whole divided by 4. That will give you answer 2.4. It's option B that is correct. Question 20. The motor of a crane lifts a load of mass 600 kg. The load rises vertically at a constant speed At 12 meter per minute, what is the useful power output? Okay, so power, very simple question. Power, we know it's force multiplied by the velocity. So as you are lifting the load, so force will be equals to its weight. Okay, and weight, we know it is equals to mg. And velocity is given. Velocity is 12 meter per minute. You have to change into seconds. So 12 meter, 1 minute is 60 second. So just put the values here. Force is mgv. It's sorry. So mass is 600. G is 9.81 and V is 12 divided by 60. That thing will give you 1177.2 watt. It can be written as 1.2 kilowatts. So this is option B. Moving to the next question. A platform is supported by a spring. A box is placed onto the platform. The diagram shows the spring after the box is placed onto it. What is the term used for the quantity marked at S? Okay, this is the initial length. This is the final. This is the change in length basically. So it is a compression. A copper wire has a length of 1.7 meter. Diameter of this. The Young modulus is given. What is the spring constant? Okay, so we have to find the spring constant. So this is L. This is D. This is E. Can we have to find K? So Young modulus relation is Young modulus is equals to FL over A into X. Okay, we don't have F. We have to change F into form of K. F is equals to Kx. So we can put it here. Kx Ax. So if you see this X will cancel out with this X and I will get K into L divided by A. Okay, we don't have the area. We know area is basically pi d squared divided by 4. You should memorize this formula, okay? So putting the values K L over, sorry, let's first rearrange this thing. Okay, first rearrange, then we can put the value. So K will be, we have to make this thing as a subject, okay? This K. So K will be equals to E into A over L. Now you can put the value. A is pi d squared divided by 4 and there is another L. Now put the values. E is 1.2 10 raised to power 11 into pi into D is given, it is millimeter. Okay, so 0.64 10 raised to power minus 3 divided by L is 1.7 into 4. Doing the calculation, we will get 22708.17. That can be written as 2.2 10 raised to power 4 Newton per meter. It's option A, that is correct. Okay. In the next question, the graph shows the extension of the spring varies with the force used to stretch it. What is the elastic potential energy of the spring when the extension is 4 centimeter? Okay, so we know area under the graph will give you the elastic potential energy. So you have to find this area. E is equals to 1 over 2 F into X. 1 over 2 F is 30 and it is in kilo. So 30 10 power 3 and X is 4 and it is in centi. So it is 4 into 10 raised to power minus 2. Doing the calculation, you will get 600. It's option C, that is correct. Moving forward, question 24. Which row describe a progressive longitudinal wave? Okay, the transfer energy in a direction parallel to the oscillation. Yes, they do. So you have to choose between C and D. Require a medium to travel. Yes, they require medium to travel. Okay, so it's option D. Okay. What is the phase difference between the point P and Q on the progressive wave shown in the diagram? Okay, so this is P. This is the first quarter, so this is 90-degree phase difference from P. And this is second quarter, so from there it is 180. This is third quarter, so this is from there it is 270, then this is 360, and then this is 360 plus 90, that is 450. Okay, so this is B. Each quarter is of 90 degree. Okay, question 26. The graph shows the variation of displacement with distance for a two progressive wave x and y of the same type in the same medium. The intensity of wave x is I. What is the intensity of wave y? Okay, so x intensity is I and its amplitude is this much. Okay, what this is basically the 1, 2, 3, 4, 5, 6, 7, 8. It's the eighth box, and each box is basically 0.5 divided by 10. So this value is 0.4. That is your amplitude for the x. Okay, let's call it ax. And for the amplitude of y, this is 0.5, this is 1, so this is 0.75. This is amplitude of y. Okay, so as we know, intensity is directly proportional to amplitude square, so we can use the ratio method. So if I take, or I can say, when the amplitude is I, or do it like, yes, when the amplitude is I, so when the intensity is I, amplitude was 0.4. And what will be the amplitude, what will be the intensity when the amplitude is 0.75? Okay, and there are square on it because amplitude and intensity is directly proportional to the square of the amplitude. Okay, so you can take the ratios to find x will be equals to, it will go there, you have to cross multiply, it will go there. So x is equals to I into 0.75 square divided by 0.4 square. That thing will give you 3.5 I. Okay, so option D is correct. In question 27, a moving source emits sound of frequency 1200 hertz. Okay, so this is the frequency of the source. A stationary observer hears sound of this, so this is a frequency of observer. This is the speed of the sound. What could be the velocity of the source? You have to find Vs. So this is from the Doppler effect. So Doppler effect is, if you see the observed frequency is less than the source frequency, it's mean they are moving away from each other. Okay, so the basic relation is for f naught is equals to fs v divided by v plus minus vs. Sorry, so if they are moving away, this thing will be added up. Okay, so this thing is vs, so we have to find vs. Let's rearrange it. I can write as v plus vs is equals to um, v into fs divided by f naught. You can take fs is equals to v into fs divided by f naught minus v, putting the values 1200 into 340 divided by 960 minus 340. Doing the calculation, it will give you 85 meter per second. Okay, so moving away and 85, so it is option C that is correct. Question 28. A light wave passes through a single slit and a diffraction pattern form. What happened to the frequency and the speed of the wave when it in diffraction? Speed and frequency only change when there is a change in medium. In diffraction, there is no change in medium, so the frequency and the speed will remain same. Frequency will never change, by the way. Okay, the equation n lambda is equals to d sine theta can be used with the diffraction grating to find the wavelength of visible light. Which quantity is not correct for use in this equation? Okay, so a is d is equals to distance from the grating. No, that is incorrect. D is basically, if you remember, it is spacing between adjacent slits, not the screen. Okay, so this is the option A. In question 30, the progressive sound wave move in opposite direction and superpose to form a stationary wave. Which statement describe an antinode of this stationary wave? Okay, in A, position where the phase difference between the two wave is 0 degree, no. A position where the phase difference between the two wave is always 180, no. A position where the stationary wave has the maximum, yes. Where they have the maximum amplitude, that is considered as antinode. Okay. In 31, a student connect two loudspeaker to a single generator. As the student walk from P to Q, this is point P, this is point Q, and they are two sources. So what causes the loud? He will hear the sound rises and falls. Okay, basically what is happening? Superposition. Okay, so there will be a high and lows. So what causes the loudness? It's diffraction, no. It's Doppler, no. Interference of the sound, yes, it is the interference. Somewhere it will be constructive interference and somewhere it will be destructive interference. In question 32, the current in a resistor of a constant resistance is 8 milliampere. Let's call it M1. The power dissipated by the resistor is P. The current in the resistor is increased to this. Let's call it I2. What is the new power dissipated by the resistor? Okay. So if you remember, power dissipated is equals to I square R. So if the resistance is constant as given, I can say power is directly proportional to I square. So same, we can use the ratio proportion method. So when the current is, sorry, when the power is P, the current was 8 milliampere and there should be a square on it. Okay, because they are, P is directly proportional with I square. Okay, and what will be the power when the current is 12 milliampere? Okay, so you can use the ratio proportion. So X is equals to P into 12 into 10 raised to power minus 3 whole square divided by 8 into 10 raised to power minus 3 whole square. Okay, solving these two, you will get 2.25. That can be written as 2.3. Okay, 2.3, and there is a P as well. So it's option D that is correct. Moving forward, question 33. A piece of wire X has a resistivity rho, length L, and a cross-sectional area A, where X has a resistance R. Okay, a second piece of wire, that is Y, is made up of a different metal. It has the same resistance, but the twice the length. Which row give a possible value for the resistivity and cross-sectional area of Y? Okay, so what we have, it should have the same resistance. So for resistance, we have relation R is equals to rho L over A. Okay, and okay, this is, let's suppose this is for R1. So for R2, we have different options. Let's check the option A. Okay, so we are checking the option A first. For A resistivity, we have to write rho over 2. Length is already 2L, that is given, divided by the area, and area they are telling us 1 by 2a. Mm, this thing will cancel with this thing, it will give us 2 rho L over A. That thing is not equals to this thing. Okay, so the resistance will be different in that case. It's not the option. So A is not possible. Let's check the B. For B, R2 will be basic relation, we know it is rho L over A. So rho is basically 1 by 2 rho. L is 2L. It's given in the question that length is double. Divided by the area. Area is A. So this 2 will cancel with this 2. It will give you rho L over A. It's the exactly same thing that there is. So this is also equals to R1. So resistance is same. This is possible. Option B. 34. A cell of electromotive force deliver a charge Q to an external circuit. Which statement is correct? The energy dissipated in the external circuit is EQ. No. The energy dissipated within the cell is EQ. No. The external resistance is EQ. No. The total energy dissipated in the cell and the external circuit is EQ. Yes, that is correct. Okay, because EQ is the total energy provided. Okay, so the total energy provided will be equals to the total energy dissipated in the internal and the external. In the next question, question 35, the diagram shows a circuit with a battery of electromotive force 60 and a negligible internal resistance. A 20 kilo ohm resistor, a thermistor, and a voltmeter is attached. The resistance of the thermistor is 20 kilo ohms. Okay, so the temperature of the thermistor decrease, and this cause the resistance to change by 50%. Initially we have this resistance is 20 kilo ohms. This is also 20 kilo ohms. Okay, you have to tell this is, they are telling us that resistance is changing. The temperature of the thermistor decrease. Temperature decrease, resistance will increase. Okay, so temperature is decreasing, resistance will increase. How much? 50%. So 20 kilo ohms, 50% of is 10 kilo ohms. So new resistance of thermistor will be 20 plus 10, 30 kilo ohms. So now we have, this is 30 kilo ohms. You have to tell the reading of this voltmeter. Okay, so what we can use, we can use the for formula for the potential divider. Okay, so that is V out is equals to V in multiplied by R out divided by the R total. Okay, so V out is basically this thing. So V out is, V in is 60, this is V in, and this thing will be the V R out. Okay, from where you are getting the output voltage. So this thing is 20. You can write the kilo as well if you want to, and R total will be the 20 plus 30 is 50 kilo ohms. Okay, so doing the calculation, it will give you 24 watts. It's option B, that is correct. Moving forward, question 36, a potentiometer circuit is used to determine the electromotive force Ex of the cell. The circuit include a second cell of unknown EMF and negligible internal resistance. Ex is less than E naught. Okay, so this is the primary condition, that Ex is less than E naught. The movable connection J can be positioned anywhere along the length of the resistance where resistance wire. Which circuit is suitable for determining Ex? Okay, so let's start from the A. In A, what you are doing, there is, okay, in A there is an issue with the polarity. This is positive, this is negative, this is negative. So they will never give you, basically the concept is for the null galvanometer. When this voltage the when this voltage across this wire and this voltage, they will be equal, the galvanometer gives you the null value, and then you can compare this voltage with this voltage. Okay, then you know they are equal to each other and you can find the unknown. But in this case, this is positive terminal and this is negative terminal, they are never going to oppose each other, so this will not give you a null reading. So A is not an option. And same is the case with the, no, acha. Let's check the B option. B is Ex is there above and this is there. Ex is less. Okay, if Ex is less, the voltage across PQ is equals to Ex. Basically, this is the whole wire, and E naught is getting only a chunk of it from this to this. So E naught is already greater than Ex. So this value will never be, this thing will never be able to balance the E naught. So this is not correct. Okay, because the PQ, if you even attach this thing here, it will have the maximum voltage. Even that voltage is not equals to E naught. So it will never give you a null value. Okay, so B is also not the option. In option C, okay, in option C, okay, in option C, this is attached with wrong side, because wherever you attach this connection, the voltage will not change because this is measuring the total voltage, or the voltage, sorry, this is measuring the current, and this current will not change because it is not connected with this connection. Okay, if you see here in this diagram, okay, by the way, we are left with only this thing, so we already know this will be the right option. Secondly, we know E naught is greater than Ex, so this whole PQ voltage is greater. So when you take the voltage of the current from this small chunk, this area, or anywhere in between, it can balance this voltage, and this galvanometer can give you a null value. So this is a possible circuit. And question 37, the principle of conservation of which two quantities are associated with Kirchhoff's first and the second law? It's option A, that is correct. In question 38, an up quark in a hadron changed to a down quark. The element changes E. What is the magnitude of change in the charge of the hadrons? Okay, so we know charge of up quark is plus 2 by 3e, and charge of down quark is minus 1 by 3e. So you have to find the difference in charges, so it will be minus 1 by 3e minus 2 by 3e, it will give you minus e. And if you have to check the magnitude, you will ignore the negative sign, it will be e. That's option C, that is correct. In question 39, a nucleus of magnesium 23 decay to form a nucleus of sodium emitting a beta plus particle and beta and particle X. What is particle X? It is a neutrino. Okay. A nucleus of U38 decay in stages by emitting alpha and beta particle, eventually forming a nucleus of 206. How many alpha particle and how many beta particle are emitted during the decay? Okay, so if you see U238 92 is changing to PB 206 and 92. So first check the masses. It is basically 238 is changing to 206. Let's check how much difference is happening here. So if you minus them, you will get 32. Okay, so each alpha have a is equals to 4, so 32 divided by 4, what you will get 8. So 8 alpha will be emitted. Okay, first thing, because the a is only changed because of the alpha, Beta does not have any mass, so it will not change the mass number. Now we have, if you change 8 alpha, so this 92 will 92 and 8 alpha, each alpha is, if you check the z for alpha, it is 2 into 8, it is 16. Sorry, this is 82, my mistake. So it is 16 that is changing, okay? And what is the change here? This is 92, this is 82. So because of alpha 16, charge number is decreased. But what you need a charge difference of 10. So in each beta, you gain plus 1. So for 6, how much you need? Plus 1 into 6. 6 beta decays. 6 beta decays and 8 alpha decays. It's option A. That's all for this class. See you in the next video, inshallah.